Okay, so welcome back to the second part. Okay, what we will be doing this semester, well, the course will be more or less the same. I mean, we will be having weekly home assignments, around 10 of them, and we will be having lectures on Monday and Friday. We will be doing lectures. Wednesday, we have an additional 2 hours that I will again use it for recitations if there is any request for recitation. And in Note to Class, I already uploaded what we will be covering more or less every week. Now, if you remember in 331, what we had done was we just looked at the static properties. We looked at magnetostatic, we looked at electrostatics, and then only at the end of the semester, the last couple of weeks, the few weeks, we looked at what happens if there's time dependence in our system. And if you remember, we had seen, for example, if there's a changing electric field that also created a magnetic field, and if there's a changing magnetic field that also creates an electric field. So that is where we will pick up this semester. So we will see that we will be discussing light mainly. First, we start with this week. We will be doing some conservation laws. Okay, we already know if you remember, we were discussing these properties that Newton's action and reaction pairs do not really work in the magnetic forces. If you remember, the Lorentz force was perpendicular to the velocity. So if you have an object, a charged object moving in that direction, another charged object moving in this direction, the force that this feels due to this one will be upward, and the force that this feels will be in this direction. So they are perpendicular to each other. They are not action-reaction pairs. So it seems that, okay, the magnetic linear, action-reaction pairs were important because of the conservation of linear momentum. If there are no action-reaction pairs, then it seems that linear momentum is not conserved. But anyway, we will see that it's not the case because we are missing the linear momentum of the electromagnetic field itself. Because we will see that electromagnetic field itself carries energy, and it also carries momentum. So that is what we will be discussing this week. And then we will start the waves and what we mean electromagnetic waves, lights, what's the polarization of electromagnetic waves. Now, polarization is something that you use quite often, whether you know it or not. I mean, your screens are using polarizers, and 3D glasses, they are using polarizing filters. All these plastic over here, they are nothing but polarizer filters. They use the polarization property of light to create that three-dimensional image. And of course, an important question will be what happens to electromagnetic waves in medium. So you know that you are probably familiar with the laws of reflection and refraction, the Snell's law, etc. So how do we derive them from Maxwell's equations? So all of these are basically related to Maxwell's equations, and we will be deriving them from those equations. And then the waveguides, the vector potentials, etc. So these are the vector potential, the gauges, various gauges. I mean, we had already described these gauges, right? So what the problem of the gauges is, okay, we have the electric field, we have the magnetic field. We also historically, when we studied electrostatics, we saw that we can write the electric field in terms of a scalar potential. And when we were working with the magnetic field, we saw that even in the electrodynamic case, when there are time dependence, we can write the magnetic field in terms of another vector potential. So when we write the magnetic field in terms of a vector potential, you see we have 4 Maxwell's equations. We have to solve them. When we write magnetic field in terms of the vector potential, we are automatically solving one of those. So that is one less equation to solve to determine that vector potential. But then we had this problem that the vector potential was not unique. There are many vector potentials that correspond to exactly the same magnetic field. And we will also see that there are many scalar potentials and vector potentials that correspond to the same electric and magnetic field. And transformation from one scalar and vector potential to another set of scalar and vector potentials that correspond to the same electric and magnetic field is what we call the gauge transformations. Especially when you advance in your studies, you will see that this gauge transformation will be an important guiding principle for us. When we study, for example, when you are taking quantum mechanics courses, you will be studying how how a particle interacts with an electromagnetic field. There, what will be important will be this gauge symmetry and the vector potentials, the scalar and vector potential. Those are the things that will determine their interaction properties. And then after that, eventually we will be looking at, if you also remember what we did in classical statics, electrostatics and magnetostatics, we just started with simple systems, simple properties, general properties, and then we looked at what will be the electric and magnetic fields corresponding to localized objects, because those are basically most of the time what is creating these electromagnetic fields, localized objects, like the atom. Atom is a very small object somewhere over there. It doesn't have a net charge. Nevertheless, it creates electromagnetic radiation. So that is what we will do over here. What is the electric and magnetic field corresponding to a single point-like moving object? This is what is linear, however you pronounce this one, potentials. These potentials are the potentials of a point object moving with some arbitrary velocity v. And the dipole for the television antennas, they are basically dipoles. So you will see that these huge towers, wires, or most of the time if you open up any radio receiver, you will see many coils. So the receivers, if you let them work in reverse, they behave like antennas, so they are very similar to each other. So if you have these long wires, what you do is you just let some current run up and down there. So that is what's a dipole. A time-dependent dipole, that is what is emitting the radiation that we receive, and our television and radio receivers, and now the wireless, they also work using similar techniques. This is how they work. And of course, we would be interested in the power radiated, and then towards the, let's say, the last 1/3 of the semester, we will be looking at the relativistic description. Now, when we are talking about the electromagnetic waves, we will see that electromagnetic waves move at the speed of light, the c. So relativity is an integral part of electromagnetic radiation. So what relativity tells us that, well, you can just, the space and time, they are more or less equivalent to each other. They just they convert from one to the other. One, when you go from one reference frame to the other one, they just mix together. So we should be able to formulate the Maxwell's equation in a similar framework. So we will be looking at how we can, first we will review what special theory of relativity tells us, what is the structure of space, and then how we can write the Maxwell's equations in a form that is nice in a relativistic framework. And then we will close the semester. And we will see that although we have 4 different Maxwell's equations, when we develop this relativistic framework, basically we can write all in terms of one equation. So first of all, it will look weird until you get used to it. And once you get used to it, you'll see that it simplifies your life a lot. And, well, the grading, again, is basically the same as the last semester. 2 midterms, 25% each, 1 final, again 25%, and homework, 25%. You will get around 10 homeworks, as I said. The midterms, the first midterm, April 1st. Second midterm, May 6th. if you don't have any objections. At least I know that these dates that we won't have any problem finding an empty classroom. This semester we won't have any problem in finding a classroom. We are just 14, we can just fit in one of the classrooms in the department. Anyway. Any questions? Pre-reports, well, I mean, last semester it was not obligatory, so there were only 2 students making the pre-reports. And to be honest, I was kind of too lazy to read them. This semester I will be having less time, unfortunately, so I will not be pretending as if I'm reading them. So if you prepare, I mean, there's the discussion forum. I strongly suggest you to read it in advance before coming to the lecture, even if there are no pre-reports. That would help you a lot. And if you have any questions, there is the discussion forum. You can post it anonymously. I will be following those discussions over there, and if necessary, I can interfere. Well, I have a question for you then. Since you don't have any questions for me, what should I change? Now, the reason why I'm asking is, okay, as I said, I'm just planning to repeat what we had done last semester. It's just on different subjects, let's say, but for some reason it just doesn't work. I mean, in the sense that, I mean, the idea, the main motivation is not to cover all these top topics, etc. The main aim of all these lectures is that so that you should learn. And I have serious doubts that we are not reaching that aim. So we are kind of failing. I mean, not just in this course, in general. I mean, we have been also discussing with your lecturer of classical mechanics. I mean, we basically are facing more or less similar problems. And no, it's just not just these 2 courses. I mean, one thing that was kind of surprising for me is that, for example, you were all my students in your first year, and we also studied electromagnetism in our first year, and now we are again studying electromagnetism in your 3rd year, and you're just, I mean, in your exams, one thing I saw was you're just trying to use the methods that you had learned in your first year. Well, for me it was kind of nice because the other lecturer told me that you were doing great in first year general physics. So you knew what you were doing and using the methods of general physics, but nevertheless you don't seem to have improved over that one. So that's also something I observe. I mean, you are trying to solve all these problems using things that you had learned, I would say, even before coming to the university. You don't seem to be learning new methods. You see, methods is more, I mean, I wouldn't be exaggerating if I say that the methods that you learn is more important than the topics that you learn. You see, for example, most of you, when coming to physics department, you probably face with all your families and friends who are claiming that you cannot do any job after graduating from physics. You will be unemployed, you won't be able to earn your life, etc. And my wife is working in an industry, in the human resources section of the industry, and she's always complaining that, she used to complain that, I mean, we don't know which job to assign to the physicist. So that was the general complaint that she was hearing. Because the thing is, the physics is not a job. It's not like engineering. I mean, if you look at electronics engineering, their topics, what is expected of them is well defined. So when you go to a job is announcing some engineering positions, it's clear-cut from the beginning what should the outcome be from that job. So that is what they are teaching them. So how to do some engines, how to do some circuits, etc. And nowadays, the engineers are realizing that they cannot come up with new ideas. So you see, for example, I was talking with another friend in some other industry. He's now the head of they are in Roketsan, they are building an academy within the industry. And he's the head, he was telling me that, okay, whenever you go to a research and development section of, I don't know, Intel or Google or whatever you like, he was telling me that you don't see engineers there. You see physicists, you see chemists, you see biologists, you see mathematicians, but no engineering. Because he was saying me that once you decide what you should build, well, building it is trivial. But the problem is, what should they build? I mean, if they want to build some device put under the skin, for example, if they decide that that should be a great innovation, then that's trivial to build. But they just cannot come up with these new ideas. Now, if you look at physics as a job with a well-defined job description, you're kind of out of luck. I mean, there's no job description for physics. But what we are teaching you is basically, I mean, you see, when with another friend, he was telling me some of the projects that they were proposing. I was like, I mean, for example, when I need to propose a project, it has to be something new. So not done anywhere in the world. It can be something small, but it has to be something new. He was telling me a project that they were trying to build some system that was built in some other place. So I was like, okay, I mean, that project has no chance of being accepted. It was already built. So he was telling me that, okay, that is an engineering project. An engineer basically builds something that is already known. So he applies a known solution to a given problem. So what if the solution is not known? So that is where the physicist comes into the game. So what we are actually teaching you, what you should be concentrating on, is if you have a question that is not solved, what are the tools that you need to use to address that problem? And that part of our department's education is failing to reach you somehow. So what should we do? So for example, some examples specific to this course. Last semester, if you remember, we were trying to discover how the magnetic field changes across a boundary, how an electric field changes across a boundary. But whenever I'm discussing with any one of you about those properties, almost none of you mentions how to derive them. But all of you are asking, what is the discontinuity? What is the expression? Well, to be honest, who cares? Can you derive it? That is what is important. So, okay, what we are discussing is already known. Your homework questions, most of them, the solutions are already known. But just take it as a game. I mean, let's say, okay, don't take it literally. You are little kids trying to grow up. And when kids try to grow up, they play. They play on things that were played, I don't know, hundreds and thousands of times before by other kids. So these questions that we are asking you are just, in a sense, we know the answer, everybody knows the answer. I mean, if you look at the internet, there are many forums discussing the answers, etc. But the thing is, it's the first time for you that you face those problems. Can you come up with a solution? So that is the skill that kind of, as a department, we should be teaching you. But somehow we are failing. So this is a general problem, not particular to this course. It's a problem that, as a department, we should also solve somehow. I don't know how, that's why I'm asking you. So here is your problem that doesn't have a solution. Because the solutions that work in some other countries for some other universities, etc., will not work for you. So you are learning the skills. I mean, this doesn't need to be mathematical skills. I mean, you are analyzing problems, quite complicated problems, in fact. Now there's a problem to be analyzed, tested. Well, you are doing experiment. Like you are a physicist, which is an experimental science. So what are the experiments that we should do to find an answer? But, you see, it doesn't work. We tried it in some other courses. So what happens in that case is, since there are so many exams, I mean, just like homeworks, you just don't care about the exams. And second problem is, you see, there are a couple of approaches to the questions. So one is forcing this to the lecturer. Okay, the lecturer does this, the lecturer does that, etc. So that is one approach to solving this problem. Your proposal is one of them. So I can do some exams, weekly exams. I mean, I can use some other time. I mean, homeworks are weekly exams, basically. But the problem is, now, I mean, you see, one thing I observe is that this police and thief game between the students and the lecturers. The lecturers try to force the students to do things, and the students try to find ways to go around those things. And then the lecturer just tries to find more strict ways of preventing the students to go around, and then the whole purpose becomes this police and thief game. So that's not something I want to foster, let's say. I mean, whenever I do some, for example, I was doing the quizzes in the first year. Now I don't do it anymore. Well, nobody worked for the quizzes.
Bence biraz önce yaptığımız konuşma yeterli olması gereken konuşma. Çünkü hani bölümdeki birçok insan hala bunun farkında değil. Hani ne yapacağını ve neden burada olduğunu farkında değil. Bunun nereye varacağını da farkında değil. Ve hani şeyden bir haber hani birçok insan hani kendi buna dahil olmak üzere. Hani biz burada öğrendiğimiz şeyler, bizim burada öğrendiğimiz şeyler belki işte 50 yıl öncenin, belki işte 100 yıl öncenin hani biliminde hani yürütülen şeyler şu an hala kullanılıyor, fakat hani biz hani 100 yıl önceki dönemde yaşıyoruz ve şu an hani güncel olarak dünyada fizik nasıl ilerliyor? İşte bu öğrendiklerimizi nerede kullanacağız? Sürekli matematik derslerinde sorduğumuz sorular işte. Tamam bunu öğrendim ama nerede kullanacağımı bilmiyoruz. Hani buralara geldiğimizde bunu fark edebiliyoruz. Yani oralarda sürekli geri çeviriyoruz. Hayır, matematik bölümünde değiliz, fizik bölümündeyiz ve nerede kullanacağımızı bilmemiz gerekiyor. Bu bence çok büyük bir itici güç oluşturuyor. Hani kendim hani bütün yaptığım çalışmalarda bakıyorum. Eğer ki hani uğraşacağım problemin nereye varacağını görebiliyorsam ve hani benim kendi içimde nereye hitap ettiğini bulabiliyorsam eğer, evet o problem üzerinde çalışabiliyorum, saatlerce çalışabilirim, oynayabilirim, düşünebilirim. Ama diğer türlü soru sormuyoruz. Hani birçok hani oturuyoruz mesela onların problemlerini verdiğimizde de hani oturup da böyle düşünmüyoruz. Sürekli drive etmeye çalışmıyoruz. Soru sormuyoruz. Buna kafa yormuyoruz. Bu büyük bir problem. Bunun için şey görmemiz lazım. Neden öğreniyorum? Ben bunun sorusunun cevabını verebilmemiz lazım. Tabii ki şey değil bu. Hani derslerde hadi güncel uygulamalarını gösterelim gibi değil ama belki biraz daha hani öngörülü olabilmemizi sağlayacak bir şeyler bulmamız gerekiyor. Yani hani biz nereye doğru gidiyoruz, nereye yöneliyoruz bilmiyoruz. Mesela hepimiz alıyoruz. Evet, klasik alıyoruz, evet. Ama ne yapacağız biz bunlarla? Hiçbir fikrimiz yok. Master, şimdi düşünüyoruz, evet master'a gideceğiz ama master'da da bu dersleri alacağız ve orada da hala bir belirsizlik var. Doktora da düşüneceğiz diyoruz. Böyle erteleme yapıyoruz aslında. Oysa ki mesela hani yurt dışındaki arkadaşlarımla konuştuğumda hani master'da ne dersler alıyorsun dediğinde benim ağzım açılıyor. Çünkü çok lezzetli başlıklar söylüyor böyle bana. Acayip enteresan. Ben diyorum ki ben yine klasik geometri, kuantum okuyacağım. Yani bir şey değişmeyecek benim hayatımda. Belki birazcık bununla alakalı hocam. Hani şeyleri görüyorum mesela. O derslerin ne kadar eğlenceli yapıldığını görüyorum. İşte Caltech'te olsun, işte Princeton'da olsun böyle hani verilen derslerde Sadece dersin teorisinin yanında işte bir şekilde örnek veriyorum. Her ders bunun için uygun değil. Belki spesifik de bu ders de öyle ama işte yanında bilgisayar uygulamaları veriliyor, makale okumaları veriliyor. Hani bir şekilde güncelle, dünyayla bağlantısı kuruluyor o dersin ve evet tamam hani ben de bu yarışmanın içindeyim diyebiliyorsunuz ama hani biz burada zaten bir taşra kasabasında hani bir üniversitedeyiz ve bir şeyler öğreniyoruz. Güzel hani falan diyoruz ama gittikçe şeyden kopmuşuz. 3 sene önce, 4 sene önce buraya gelirken ki güdümüzle devam edemiyoruz. Onunla devam etmeye çalışıyoruz. Diyoruz ki hayır yani ben değiştim, hayat değişti, bakışım değişti ve ben neden hala o güdüyle gidiyorum gibi bir çelişki oluşuyor.
Now, that's something I observed also this year. Since I already know how you were behaving 3 years ago, I see a complete change. I mean, especially the students who are now in this classroom, you were the most active in the classroom. Now, even Sarjan is not asking questions. Well, there are a couple of issues. One thing that you mentioned, for example, there we are thinking, is, for example, these homework assignments. Okay, I'm a defender of the homework. I mean, you should be given homework, you should be solving exercises, etc. But there's a drawback in giving homeworks. So I give you homeworks which are, I mean, I also use the homework as a tool to force you to go beyond your limits. I mean, if you just look at the homeworks, most of the time the homeworks are difficult than the exams. I mean, since homeworks you have more time, I'm kind of forcing you, but at the same time, homework are just taking away your time that you can just sit down and think about what we are doing. The same thing will happen if I do exams every week. I mean, you see, on one hand, you should be spending time on thinking about physics. Homeworks is one way of doing it. But as I said, homework is just one way of doing it. And if I don't give homeworks, when we don't give homeworks, then you have more time that you can work on physics, you can think of physics, you can discuss on physics. But at least from the side of the lecturers in the department, our impression is that you won't be using that time to discuss physics or work on physics. So on one hand, we are trying to solve one problem, but at the same time, this homework is trying to solve that problem. But at the same time, it's also creating that problem also, unfortunately. So after some time, especially if the homework questions are available on the internet, you're just tempted to just look up the solutions on the internet, and everybody is. Now, another problem is, as you said, that is something that we are trying to implement, but we couldn't manage yet. Just these demonstrations for all the courses, not just one. I mean, that is something we are trying to do in at least the first year. The general physics, that was something I was trying to do, let's say. I mean, hopefully we will be doing it more and more in more lectures, but we are not there yet. At least today I have some 3D glasses. Okay, let's give a break now. Let's play with these 3D glasses for the time being. And in 15 minutes, we will start the lecture, the actual lecture.